always of a force. When we say work is equal to F dot S is equal to magnitude of F, magnitude of S into cos theta, remember this is the work of a constant force. The force could be variable also, we'll come to that. So when we say work is equal to F dot S, remember this is the work of a constant force. Whenever say work is always of a force, let's take the case. Over here, this is theta and this height is h. There is a block, mass m, all surfaces they are frictionless. This body has been released from rest and it is coming down. First is, what is the work done by normal reaction? That is, we are interested, work done by normal reaction. You know, normal reaction is in this direction. Normal reaction is in this direction. If we see, this is h, this is theta, so hypotenuse, that is, if we take it as x, we don't know the value of this. We know sine theta is perpendicular by hypotenuse. Hypotenuse comes out to be h by sine theta. We may be using this value, and so I write over here, that is, this value comes out to be h by sine theta. This is the length of this inclined plane. This is inclined at angle theta, and from here the body is released, initial velocity 0. We are interested in finding what is the work done by normal reaction. So when we are asked to find the work done by a force, simply first thing is look at the force, look at the where the displacement, and what is the angle between the two. Over here, the force is in this direction, this displacement is in this direction, the angle is 90 degree. So work of normal reaction is, normal reaction, it may be whatsoever it may be. We know that is, otherwise we know that is mg is going to be here, mg cos theta is going to be normal reaction. So anyway, and we have done these things quite in detail in laws of motion. If there is any confusion, I would strongly recommend you, that is, if you wish to understand and have a very good grasp over mechanics, your laws of motion, it should be perfect. So please, you can go to that lecture. Over there we have done lots and lots of things. We have done free body diagrams, we have done friction, we have done pseudo forces, and we have done so many questions of blocks and pulleys and movable pulleys. So I will recommend, that is, you can go over there first, do that chapter, so it will consolidate your understanding of laws of motion, force, etc. But in case you wish to continue over here, that is, there should not be any problem. So over here, normal reaction is here, displacement is over here. So F is this, displacement is h by sine theta, and angle, that is, we have to say cos theta. Cos theta is not this. Now the cos theta, cos of angle, what? Angle between the force and displacement vector, between normal reaction and displacement vector. Now that is the angle. That is going to be cos 90 degree. Cos 90 degree is 0, so the work done by this is going to be equal to 0. As we had understood the case of work done by the centripetal force, where the centripetal force, we have said that is centripetal force is always in this direction, displacement is, when it is moving like this in this direction, so displacement vector is in this direction, force vector is in this direction, angle between the two is 90 degree. Work done by the force when it is being applied at an angle of 90 degree to the displacement vector, then the work done is 0, because cos 90 is equal to 0. And the same thing is happening over here also. The normal reaction is here, displacement vector is here, and the angle between the two vectors is 90 degree, pi by 2 radians, so that's why the work done is going to be equal to 0. Now someone says, what is the work done, work of mg, that is gravitational pull. Now mg is acting this way. One way is just to understand it, that is, what happens if we find the work done by its components. That is, this mg can be represented by its two components. One is, obviously this angle is going to be theta. We know the angle between the two intersecting lines is theta, so then the angle between their perpendiculars, that is also going to be theta. So if this and this between these two lines, the angle is theta, then the angle between the perpendiculars, that is perpendicular, this is the line which is perpendicular to this, is this line perpendicular, or this line is perpendicular to this line is perpendicular. So the angle between this and this is theta only. So this is mg, this angle theta. So with this adjacent side, where this is theta, with this, obviously, and when you draw the rectangular components, you know very well that this will come out to be mg cos theta, and this component will come out to be mg sin theta. So now what we are doing is, first thing what we are doing is, we are saying, let's, instead of finding directly the work of mg, can we do, that is, work of mg is also equal to work done by its components individually. That is, because this force is now being represented by its components, so it should be equal to work done by mg cos theta plus work of mg sin theta. Remember, work is always a force. Over here, mg cos theta is we are considering as force, and over here mg sin theta is we are considering it a force. Now, when we have to consider a force, so once again, work is equal to F dot S is equal to magnitude of F, magnitude of S, and cos theta, that is where theta is the angle between the force vector and the displacement vector. Over here we see, when we say mg cos theta, work of mg cos theta, what is the force? Force is mg cos theta. Now this is gone. This force has been represented, now is being represented by its components. So we can either have a resultant force or we can represent it by its components. So over here it is being represented by its components. So let's remove the resultant force or net force. Work of mg cos theta is mg cos theta, that is force, into displacement. Force is this way, displacement is this way. Now we are finding work of this. So please do not consider any other force. We are purely finding the work of mg cos theta. So just look at what is the force and what is the direction of displacement. Displacement is in this direction. So what is this thing? Displacement h by sin theta. And what is the angle between the two? Angle between the two is cos 90. So obviously this will come out to be 0. But over there we have to find the work done by mg sin theta also. Mg sin theta. Obviously we are using this because the magnitude of force is given, the magnitude of displacement is also given, and the angle between the two also is given. So we are using this. Mg sin theta, force into displacement. Displacement from here to here. It is h by sin theta. And the angle between the two. Angle between what? Angle between, now we are talking of this force, mg sin theta. And displacement is also in this direction. The angle between these two vectors, they are parallel vectors. The angle is going to be equal to 0. So this is going to be equal to cos 0. So you know cos 0 is equal to 1. Cos 0 degree is 1. So this comes out to be plus mg sin theta into sin theta, h by sin theta. Sin theta cancelled. So it comes out to be mgh. So this comes out to be mgh. So work of mg, the work done by gravitational pull when the body comes from here to here is mgh. This comes out to be mgh. Can we do it directly? Let's say instead of breaking into components, if we are not broken into components and we are just bothered about mg only, why to break into components? Anyway, just for the learning purpose we have broken into components, but otherwise we could have directly done it. So mg is here. So work of mg is going to be force. Mg is given, force is given, magnitude of force is given. Displacement, is it given? Yes, it is given. H by sin theta. Is the angle between the two is given? Is the angle between this mg and this is given? Yes, this is the angle. What is this angle? So if we take it as this angle is theta, suppose this angle is theta, so this is 90, so this is going to be 90 minus theta. So we will say cos of this angle, not this angle. Force is this way, mg is this way, displacement is this way, angle between the two is going to be now this is theta, this is 90, sum is going to be 180 degree, so this angle is going to be 90 minus theta. So it is going to be cos 90 minus theta. So obviously cos 90 minus theta is sin theta. So it comes out to be mg h by sin theta into sin theta. Sin theta get cancelled. So work of mg comes out to be mgh. It comes out to be absolutely same as we have calculated over here.